Example 2. Sketch the graph of the polynomial function. So we're going to look at A. Okay, and we want to know what the degree is. So it's harder to see the degree than when it's just a normal polynomial function. Like we're cool with these ones because that's the leading coefficient. That's the degree. And this is the constant, right? We remember that from 3.1. But it's hard to see when it's separated into factors. So you'd have to think of what it looks like when you triple FOIL it all back together. Or you could just think of all the front pieces. So we have an x here, an x there, and an x here. So if we multiply those all together, we have a positive x cubed. And our degree would be 3 then. All I did was multiply x, and x together. I took all the leading pieces. Okay, so then the degree, I think it'll show up here, is 3 because of those pieces. The leading coefficient would be a positive 1. Okay, and now we can go back to the stuff that we remembered in 3.1. What would be the end behavior? Like which quadrant would it be in based on odd degree, odd degree, positive leading coefficient. Odd, positive is like, it's going up the ski slope, right? So here's our quadrants. So it should be like this one. Quadrant 3 to quadrant 1. Quadrant 3 to quadrant 1. Okay. The zeros are the x-intercepts. What are the x-intercepts in this first equation? I'm just going to erase this. So the zeros or x-intercepts can be just found by looking at our equation. So the x-intercepts for this one is always what makes each of these pieces 0, right? So it should be 1, minus 2, and minus 3. Okay. Okay, the y-intercept works the same way as how we've always found a y-intercept. We've always found a y-intercept by putting 0 in for your x's. It still works that way. So if I'm finding my y-intercept, I put 0 in for my x's. Okay, so this gives me minus 1, this gives me 2, this gives me 3. So if I multiply those all together, I get negative 6. So that should be what my y-intercept is. And then it says intervals where the function is positive and where the function is negative. So this is the point where I would probably draw this so that I can see the picture and then do this last piece, okay? Because in the question it says sketch the picture. So, easiest thing to do on your picture is mark your intercepts first. So your intercepts we said were 1, minus 2, and minus 3. So those are our x-intercepts. So minus 3, minus 2, and then 1. And our other intercept was y is equal to minus 6. So our y-intercept is 1, 2, 6. Okay, like that. Okay. Another important part is where our picture, our end behavior. Right? So we know it's starting in quadrant 3 and it's going to end in quadrant 1. So I would just put a little arrow like this and an arrow like this showing I'm starting here and I'm going to end up over in quadrant 1. Okay, so now this is where the multiplicity comes into play because this one has a multiplicity of 1, this one has a multiplicity of 1, and so does this one. Right? So they're all just going to cross at each of those intercepts. So that just means I'm going to come to minus 3 and I cross. Then I know I have to go to minus 2, so I'll turn around and I'll cross there. And we have to go through our y-intercept. And then we must turn around and cross through this intercept. And that's roughly what our sketch would look like. Just meaning we've crossed at all these points, and we've still started in 3 and ended in 1, and we've hit all our x and y intercepts. Okay, and to finish up this example, if we're looking to see where we are positive, remember that's the things in the upper part of our graph, so it's these pieces here. Okay, so we are positive. X has to be greater than minus 3. Oops. Should I just put it in a small note? Okay, I'll hit it. X has to be greater than minus 3, but less than minus 2, because that's this chunk right here. Greater than minus 3, but less than minus 2. But we also have to include that the picture's going on and on this direction. And so it's also greater than 1. So x is also greater than 1 when it's positive. Okay, and then the negative stuff, you'll notice we're on this side of the negative 3. So x has to be less than minus 3. And we're in between the minus 2 and the 1 on this piece. So x has to be greater than minus 2, but less than 1. Okay, when we have a situation where it's a polynomial that needs to be factored, let's see if we can take anything common out first. So we'll divide by negative 2. So that leaves us with x cubed minus 3x minus positive 2. Okay, and then let's use, we're going to try to find a factor so that we can factor this down more. So remember, if we don't have a factor, we can look at our 2. And multiples of 2 are 2 and 1. So that means that we could try using positive 1 or negative 1, positive 2 or negative 2 to see if they're a factor. So let's do that remainder theorem. And let's just try subbing in 1 and see if it's a factor. So say I put 1 in. I'm going to get 0. So that means 1 is a factor. So that means that this guy would be a factor of this equation. So we can use 1 in our synthetic division. So remember, we use all the front pieces. So it would be 1 here. We need to have a placeholder because this guy goes from the power of 3 to the power of 1. So we'll have to put 1, a placeholder, a minus 3, and then the 2. So you bring your 1 down, and we multiply 1 times 1 is 1. And then we add going down. 0 plus 1 is 1. Multiply across. 1 times 1 is 1. Minus 3 plus 1 is minus 2. 1 times minus 2 is minus 2. You get 0. So we write this equation as no x, x, and then x squared. So we have an x minus 1, and now this is our factored equation, and we can still factor that farther. We can think what multiplies to minus 2, but adds to 1. Multiples of minus 2 are 2 and 1. So we can break this down as x and 2, x and 1. And it would be a positive 2 subtract 1 gives us positive 1, and 2 times minus 1 gives us a minus 2. So these would be our factors. And if we were going to write this considering multiplicity, since there's 2 of these guys, we would just write x minus 1 squared, and then x plus 2 as our factored equation. Okay, I'm going to take that equation that we've just factored, and I'm just going to put it on a blank screen here so I have a little bit more room. I don't want to degree and the leading coefficient. So remember, to find the leading coefficient and the degree, take all the front pieces with the power. Okay, so we're considering all those pieces. So we have a minus 2 times an x squared times an x. So we have a minus 2x cubed. Okay, so our leading coefficient would be minus 2. Our power would be 3, so that would be our degree. And then we can find our y-intercept, remember, by just either looking back at our original equation, so our y-intercept would be minus 4. So maybe the easiest way. Or you can sub in zeros for your x's and solve. You get minus 4. If we wanted to look at end behavior, so we have a negative and an odd power. So a negative and odd is going down the ski slope. Remember, so this is from quadrant 2 to quadrant 4. And the zeros for this one, so our x-intercepts are 1 and minus 2. And the multiplicity for the minus, or for the 1, is 2. And then we should be able to draw our picture from this. Okay, so our x-intercepts are 1 and minus 2. Our y-intercept was minus 4. We know we're starting in quadrant 2 and ending in quadrant 4. Okay. On the minus 2, it just has a multiplicity of 1, so it's just going to cross. And then we've got to go through our x-intercept point, or sorry,